Welcome back, Math 30-1. In today's lesson, we're going to be looking at graphing rational functions. So just a little start off here, we have to really know what are our asymptotes, our vertical, horizontal, and points of discontinuity. So these are the main things that we're going to be learning about in this class, okay? So here we go, we have our asymptotes. Now consider this function where n of x and d of x have no common factors. So if they have no common factors that can't be divided, what is a vertical asymptote? So the vertical asymptote is always we just make d of x equal to 0. And then we solve for x. Okay, so it's when x, what makes the bottom value 0, or what x will be to get a 0 in our denominator, that is going to be my vertical asymptote. Horizontal asymptotes, we have three different scenarios here to look at. We have if the degree of our numerator is less than the degree of our denominator, then y is equal to 0 is our horizontal asymptote. Okay, our next one here says if the degree of the numerator is equal to the degree of the denominator, then the line y of a over b, meaning the leading coefficient of the numerator divided by the leading coefficient of the denominator, that is going to be my horizontal asymptote. Okay, and these are the leading coefficients. Okay, now if the degree of the numerator is greater than the degree of the denominator, then there's no horizontal asymptote. Alright, so now we're going to do a little bit of an investigation here. So now let's take a look at this here and consider this function. It first starts off says, does this function have any non-permissible values? Well, can we ever make it so we're going 1 divided by 0? Well, no matter what, even if x is negative, if we square it, it's going to be a positive. So there's no way we can make my denominator equal to 0. So there are none. Okay? Now state the domain of the function. Well, x could be anything. It could be positive, negative, and 0. Because 0 plus 1 is 1. So x is an element of all real numbers. We have x such that x is an element of all real numbers is my domain. Okay? Now it wants to know what is the maximum value that will occur. So if we increase x, so like 5 squared is going to be 25, 26, 1 over 26. It's going to be a very small number. If I have 1 squared is 1 plus 1 is 1 over 2. That's not quite as small. Even if I put negative 5 squared is 25. So the smallest we could get our denominator is by putting x 0. So it is when x is equal to 0, or in other words, when f of 0 is going to give us our smallest denominator, which is 1. Okay? So my max is equal to 1. Okay? Now it says, explain why the value of f of x can never be negative. Why can it never be negative? Well, no matter what, when we square a negative, it's going to be a positive, right? And my numerator is a positive, because both the numerator and the denominator are positive. So I could say both n of x and d of x are positive. Okay? And that's why for that one. So both my numerator and denominator are positive, therefore I can never get a negative. So does this function have any zeros? Well, I can never make it equal to 0, so no. Okay? Use the answer above to suggest a possible range. Well, my range is going to be, we're going to look at y such that we want y to be greater than 0, but y must also be less than 1 and equal to 1. Okay? And y is an element of all real numbers. Okay. So if I was to graph this on a graphing calculator, this would look something like this. Oh, it comes more down like that. Okay? So let's review this a bit more here. It says, does the graph of the function have a vertical asymptote? Nope, none. Okay? Does it have a point of discontinuity? Not that we have, none. Okay? Does it have a horizontal asymptote? Well, yes. If we look here, it's never going to hit 0 on this way, and it's never going to hit 0 that way. It's going to get infinitely close, but never quite hit. So yes, at y, is equal to 0 is my horizontal asymptote. Okay, so now let's take a look at part 2. It wants us to graph, so it has a graphing calculator, has produced each of these 4 graphs. Okay, so for part A, it says state the equation of the asymptote if any are in the graph. Well, let's take a look at this one here. This first one, yes, I have an asymptote at y is equal to 0. Now this one here is a tricky one, and that is true because our denominator is greater than our numerator, so it follows our law at y is equal to 0. Now this one here, our denominator is greater than our numerator, but yet it looks like we actually cross the x-axis. But if I look at it, we forever are approaching 0 on this side, and forever are approaching 0 on this side, but never quite hit. So in this one here, I'm going to say yes as well, at y is equal to 0. Okay? Now this one here, at x squared over x squared, well, I look at it, we have right there is my horizontal asymptote, so it's going to be at y is equal to 1, because we go numerator divided by denominator since my things are equal, since my coefficients are the same, so it's going to be those, and my degrees are the same. Now, let's look at this one here. My numerator degree is bigger than my denominator degree. So this one's, and we look at it right here, it's going to cross, and it's always going away, so this one is no. Okay, there's none. So, do the equations agree with the rules for the asymptotes in the first lesson? Yes, they do. Okay, we're at the very beginning. So y, when x is approaching infinity of the graph, approaches the asymptote y equals 0 from above. So if I look at this, as we approach infinity this way, we are always getting closer to my x-intercept, okay? But as we approach negative infinity, it's coming from below. Now, so we're always going this way, coming from below. Now, why is that happening? Well, if I look at this, as x is from the positive, all of my x values are going to be positive here. So I look at this, we have positive divided by a positive. So in that case there, as x approaches infinity, both my numerator and denominator are positive. Positive, okay? Now, let's take a look as x approaches negative infinity. So we're looking at the negative side here. So that's when every x value is negative, we are getting closer to 0 to our horizontal asymptote. Now I look at as x approaches negative infinity, well that means x's are negative. Well, negative x squared is going to give me a positive. So d of x is positive, and my numerator is going to be negative in those. So a positive divided by a negative, or a negative divided by a positive, is always going to equal a negative. So that means it's always approaching from below. And as we get closer to 0, it is bigger, and then it gets infinitely closer. Okay? Now it says explain why the graph x squared all over x squared plus 1 has no points in quadrant 3 and 4. Well, this one has no points in quadrant 3 or 4 because no matter what, I can't get a negative number because there's no negative number. Both x squared and x squared plus 1 will always be positive. Because anytime you square a number, it's going to give you a positive. Okay? Alright, so let's take a look at this class example here. It says consider the following functions. Okay? So we're looking at these 1, 2, 3, 4, these 10 functions here. Without sketching the graph of the function, determine which have no discontinuities, no vertical asymptotes, horizontal asymptotes, x-axis, the x-axis horizontal asymptote, and asymptote of the equation is equal to 1, and points of discontinuity. So in order to start this off here, I'm going to have to do some factoring so I could look at this and figure out a little bit more. Okay? So I look at this one here. X squared minus 4, well, that's a difference of squares, so that's going to be x minus 2, x plus 2, all over x squared plus 4. Okay, let's take a look at this next one here. I have a difference of squares on the bottom, so that's x plus 4, all over x minus 2. And then we're going to have x plus 2. So nothing simplifies there. Let's take a look at my next one here, d. This is going to be x plus 2 all over x minus 2, x plus 2. Well, these x plus 2s will cancel off, so I'm going to be left with 1 over x minus 2. Okay? Let's take a look at e. Well, that one can't be simplified. Leave as is. Let's take a look at f. Well, bottom can be simplified, so it's going to be x squared plus 4 all over x minus 2, x plus 2, and now we leave as is. Okay, and we look at this one here. Well, I could factor out a negative 1, so it's going to give me x plus 4 all over x squared plus 4. That can't be simplified anymore. Leave as is. So this one really should have left as is. Now we look at my next one here. My top could be, my bottom could be simplified. So if I factor out a negative, I'm going to be left with x squared plus 4 all over x squared minus 4. So that's going to be x squared plus 4 all over x squared minus, or x minus 2, and x plus 2. Nothing can simplify there. This one here, we have x squared, x minus 2, x plus 2, all over x plus 2. This could be simplified to just x minus 2 is my answer. And my last one here, I could factor out an x, and we have x, x squared, so we have x minus 4, and we factor out an x, that's going to give us x minus 2. And we look at this here, I'm left with x minus 4 all over x minus 2. Okay, so now we look at A, and A says no discontinuities. So that means one where we can't get the bottom equal to 0. So which ones can we never get the bottom equal to 0? I look at it, we have B here, so B, and I keep on going, and when I simplified it, I also have G. So both B and G, well, we can never get the denominator equal to 0. So now we look at no vertical asymptote. So that's going to be also B and G, because we can't get the denominator equal to 0. And we look at I here. If we look at I, we're able to cancel off. So it has a point of discontinuity, but it doesn't have a vertical asymptote. So that's going to be I. So now we want no horizontal asymptote. So which ones have no horizontal asymptote? I'm going to go back here to my horizontal. And so if we want no horizontal asymptote, that means n of x must be greater than d of x. So my numerator has to have a bigger degree than my denominator. So which ones here have a numerator with a bigger degree? E. And I keep on going. I and J. Okay? Now it says the x-axis is the horizontal asymptote. So we want the x-axis is the horizontal asymptote. Go back to my rules. So if the x-axis is the horizontal asymptote, which is y is equal to 0, that means the numerator must be less than my denominator for degree. So let's look. Which ones here is the numerator less than the denominator? I'm going to have C. So put in C. And we have D. Keep on going. G. G. And that's it. Okay? Now it wants the horizontal asymptote for the equation y is equal to 1. So y is equal to 1. In this case here, we want my numerator must be equal to my denominator and my coefficients must be the same. So y is equal to 1. So I look at this here. We have A will work. So I'm going to put down A. And we have, let's take a look, A, B, F. So A, B, F. And we have H. And that's it. Now, points of discontinuity, that's where we were able to divide, so that's only going to be I for points of discontinuity. So now it wants us, for classroom example number 2, algebraically determine the equation of the asymptote and the coordinates of the points of discontinuity of the following graph. So state the domain and range of the function. Okay, so first step here I want to do is I am going to factor my bottom. So we have f of x is equal to 2x subtract 1 all multiplied by x subtract 5. And that's going to be, here we have x minus 5 and x plus 3. Okay, so what do I know? I know x cannot equal to 5 and negative 3. Okay? I cross this off. I have a point of discontinuity. So at x is equal to 5 is a point of discontinuity. Okay? Now we're left with here 2x minus 1 all over x plus 3. Okay? Now I also look at this here. I have a horizontal asymptote at, my degrees are the same, and so it's going to be n, my numerator, divided by my denominator. So my numerator here is 2, because it's 2x squared. So my horizontal asymptote is going to be at y is equal to 2. All right? Now, we also have a vertical asymptote at y is equal to negative 3. Okay? So now let's look at my domain and range. So my domain is, we have x such that, and we have x cannot equal to, I have 5 and negative 3. Okay? Now we're going to look at my range. We have y such that, now what is my point of discontinuity? It's when x is equal to 5, so I'm going to plug that in here. So if I have 5, that's going to be 9 over 8, so it's 9 over 8. So we also know that y cannot equal to 9 over 8. So y cannot equal to 9 over 8. And we also have here my horizontal asymptote is 2. And we have 2, okay? Comma 2, and y is an element of all real numbers.